AP Cram, Calculus AB, Free Response Exam Review. Question 28. Volume of a solid. Write isosceles cross sections. Let R be the region enclosed by the graph of f of x is equivalent to x to the fourth minus 2.3x to the third plus 4, and the horizontal line y equals 4, as shown in the figure. Region R is the base of a solid. For this solid, each cross-section perpendicular to the x-axis is an isosceles right triangle with a leg in R. Find the volume of the solid. I'll give you a moment to think about your answer. All right, so basically, in order to find the volume of a solid that is perpendicular to the x-axis but has extensions of right isosceles triangles, I'll show you what that looks like. So maybe it looks something like that. You know, this is like a leg, and then you can't immediately tell. And there's a series of these like the whole way through. Yeah, so just imagine something like that, okay? And they're right. So the thing about a right isosceles triangle is that like the base and the height are equivalent to each other. So that will make finding the volume easier, because the volume of something like this is just the base times the height times the depth. And we know that we can just integrate the volume by doing these imaginary cross-sectional areas from the limits of integration. And the first step is to find the limits of integration. In order to do that, you can watch the beginning of video 27 of this series, because I show you how to set f of x equivalent to y is equivalent to 4. So you have 4 is equivalent to x to the fourth minus 2.3x to the third plus 4. And you figure out that when you solve for x, x is equivalent to 0. So it should really be over here. And this is going to be 2.3. So you integrate 1/2 times the base times the height. But we already said that the base and the height are equivalent to each other. And so let's figure out the height. The height of this triangle, we can consider like the change, you know, in the length from y equals 4 to f of x. So we can just do 4 minus f of x as the height. And the reason why it's 4 minus f of x is because for the region of integration that we're looking at, 4 lies above f of x, okay? So that's why we're doing 4 minus f of x times the depth. And we can say that the change in x, which is simply another way of saying dx, is the depth. And there might be a lot of you where this formula isn't readily apparent, but this is going to be the volume of this figure. And you really just can't get this by a set mathematical formula. You really have to read the question stem well and then look at the dimensions in the graph to figure this out. So again, we have our limits of integration from 0 to 2.3. Then we have the formula for the area of a triangle, 1/2 the base, which is going to be the same as the height. And we figured out that the height is 4. That's where we get this 4 from, minus f of x, okay? Because the limit of the height runs from here to there. and here we have f of x. And if we multiply that by each other twice, it's going to become a square. So that's why this is squared instead of just writing out the base times the height twice. And then we have our depth, because we're not finding area, we're finding volume. So we need one more dimension, a third dimension, and that's going to be dx. Okay? So when you take the antiderivative, you distribute the 1/2, you square each term, and then you separate each term and solve for the antiderivative. And when you analyze that between 2.3 and 0, you get 3.57 units cubed, or 3.573 units cubed. All right. If you need more understanding for how to solve this type of problem, you can look at flashcards at 27 of this series. It's like it takes the volume of a solid of revolution